Okay, so we got up to this sheet here, and basically we were looking at something called slope fields, right? And so the idea with the slope field is the key thing that you need to know is that when we look at them, what do these actually represent? These represent the gradients of the possible curves which are solutions, okay? That's the takeaway from this, right? And one way you can think about it is, if you look at this guy, these lines, these isoclines, or isolines, however you want to pronounce them, are kind of like these magnetic field elements. You see all these little divots and you see all these little lines. And what they actually represent is they represent the gradient at particular points, okay? And so these are what we call all the possible solutions to this. This is a visual approach to it, okay? Algebraically, we can find a general solution and we can find a particular solution. That was weird.
What? That's brown out.
I don't know, but then the projector's... Oh, no, never mind. Okay, let there be light, as they said. Okay, cool. So, we looked at this before and we said a particular solution has to have what we call initial conditions. So it has to go through particular points. So if you go to B, for example, right, if you look at 0, 0, which is the point over here, right, I'll fill in that spot over there. But if you think about following along, this is actually like a fun little activity. Like if you think back to connect the dots back when you used to do those, literally what we need to do is quote unquote connect the dots of these little gradients, okay? So again, it's going to be an approximate kind of thing, but it looks like, what kind of shape does that look like? Parabola. What about 1, 3? Matt, are you writing all of these isoclines down? 1, 3, we go across 1, up 3. All right, so we have 1, 3. I think we did that already, didn't we? Okay, cool. Next one here. We've got a particular solution through these different points. Remember, these are two different particular solutions, right? So these aren't usually combined. They're just getting you to practice on the same kind of curve, right? So 0, 1, we're at 0. We go up 1 here. Go across like that. Do you guys get something that looks like that? Yep. All right. Harry, you can continue along for me.
That makes sense.
Cool. Yeah, looks good. First, I had to start with the actual point that's there, but that's okay. All right, next one, let's go on this curve. James, you get these ones?
There you go.
Nice. All class.
All class. Wow. Wow.
Yeah.
That's pretty wonky.
Let's have a look. What do we think?
It's got 0 at this, so I'm sure you can cross it.
It doesn't have, say again, sorry? So minus 2, 0, we're over here, right? So let me just clear up these again. I don't know if that was wrong. Okay. So if you zoom in, right, and you look at minus 2, 0, which is this point here, right? That is a horizontal, not horizontal, like a diagonal line, right?
I thought we were just drawing a random one. I didn't see the point on the...
Sorry, yeah, no, there are particular ones that we're looking for, right? But the idea, I emphasize this idea of connect up the dots because it has to kind of follow along naturally a path that's presenting itself, right? And if you look over here, what do you notice over here? There are some horizontal lines, okay? And so if we had a solution there, obviously that solution should go across like so, okay? But what it means is if we don't have any solutions exactly on that line, then it has to kind of follow that path alongside it, right? And what does that kind of generate? Well, yeah, and it generates something that looks like inverse tan, but it also generates a horizontal asymptote, okay? So if there are horizontal lines that are present in these differential equations, then it tends to create a horizontal asymptote there, okay? And the same thing for 2, 0, so cross 2, up 0, right? It's going to present itself as a horizontal asymptote that's kind of poking that smiley face, okay? Questions about that? Does that kind of make sense? Right? Okay, do you guys get the idea? Do you want to do a couple more just to keep practicing? Yeah, try an E and F for me. So again, same idea, I'm going to be going up to 0, 2 and connecting up these guys like so. Again, it doesn't have to be like super accurate, but it does have to kind of reflect what's going on here, right? Negative 2, 0, I always put the first point there. We'll connect that up. And the next one, 1, 1, and negative 2, 1. So 1, 1 will go over here. Now here's the interesting thing. What happens after the 1, 1? Where would the isoclines kind of match up?
Why didn't we put anything that like
point.
At what points?
Like they don't put like a line on the number line.
Oh, that's a good question. I'll talk about that.
Do you have an answer?
I do, yeah, but I need to do this in the next example. Yeah.
So just ignore it?
Well, if we zoom in, there's like a very faint, I don't know if you guys can make it out. It's very faint, but I think at the origin, at the number lines, can you see anything there? Any isoclines there?
Oh.
Yeah, it's very faint. You blink, you miss it kind of thing. What do you see there, Eva?
It's 0, so good.
There's like a horizontal line, yeah, that's
Yeah.
right.
Whoa. Like that? No?
Yeah, so you have to do a bit of guesswork here.
Which line does it connect to?
See, they're not even good.
Again, it's doing it roughly because I don't give you really enough points, right? As you kind of noticed.
I'll just put it in that
Yeah,
side.
that's right. Yeah, that's right. Yeah.
That looks wrong.
And then you'd also probably do the other side as well. Like there's some intuition. Remember how we went back to this one and I was like, here, although this one's exactly horizontal, if we have some stuff around it, it's kind of getting closer to that. And then it's going towards it but never reaching, right?
Yeah.
So the same idea kind of here is if it's going towards this line here, it probably wouldn't reach the origin exactly. It might, but then it would probably bounce back up and do that. Yeah. Okay. There's some sort of intuition of what's going on there. -2, 1. So we're going across -2, down 1. No, up 1. Sorry. -2. Oh, it kind of passes through that as well, doesn't it?
Does it go through 0?
Something like that, maybe. Yeah. Okay, so those are the two that are happening there. And again, right, it's these questions, they're not meant to be an exact kind of thing because we're looking at this from a visual perspective rather than an algebraic one. We will look at the algebraic one at the end of this lesson or next lesson, depending on how we go, okay?